We're done with that. After sharing a few zeros of this connector, key components, and the manufacturing process of the components, some key features of our connectors. What are your characteristics? Correlation, and this quality consistency of the connector, except for the parts of the connector, injection molding, stamping column. This column, these manufacturing processes, our main connector. Do you still need to assemble it together? What about during this assembly process? We will generate some other possible hidden dangers. What about this hidden danger? During the assembly process? Well, mainly reflected in 2 points. Mainly appears in 2 points. How about this one? It is also based on our connector itself. We have two obvious characteristics. Well, let's talk about connectors. We all know that we are concerned about connectors. One is called mechanical properties. It's called mechanical properties. The other one is called electrical characteristics. How about during assembly? Our main reason is because of the structure. We assemble structures. So in the process, we're all related to mechanical properties. The biggest and most obvious feature of the mechanical property, cry. So what? In our continuous production and assembly process, it generates the first force related. It's called retention. What about this retention? It's between our terminals and plastic. How can the terminals be stable? Keep it firmly in the plastic, not to be withdrawn. Or is it a mistake? What about the retention of the refund pin? It is to measure the quality and stability of our connector products. Or function. Achievable. A very, very important metric. What about the same? There is another force in our connector. Call our insertion force. What about this insertion force? Is it a measure of our connector during the application process? How good is this applicability? Just like our power strip. My plug is very, very difficult to plug in. There are some power strips in the house. Is that the case? Household plugs are very difficult to insert. Or after plugging it in, want to pull it out? It takes 9 bulls and 2 tigers. Then this X8 force. Is it to measure our connection during the application process? Is the applicability good or bad? It's a fundamental reason. What about these 2 cases? It all has one. Does it all have one characteristic? Does it all have one characteristic? And what is the hope? To a suitable degree, not too big. It can't be too small. What about retention? Is it structural or is it a destructive one? Usually, we will put it inside the plastic hole, right? We will put a terminal. Put it through interference or through. Is it through some kind of structure? Let it be stable inside. Stop in one direction. Or is it permanent? Embed it in. And so it creates a holding force. Then this retention. It's about plastic. It affects the structure of the entire product. Is there some damage? There is some damage. This is accompanied by a state of injury. So the force can't be too large. Of course, it can't be too small. If it is small, it cannot realize the function of the connector. But it's too big. Its damage will become very large. There will be this so-called life cycle. It's a question of reliability. So how do you maintain this force? At an always normal level of size. What is this about our manufacturing process? The stability of the product, stability of the manufacturing process, consistency with this manufactured size. The requirements are very high. Although we are in this place now, what kind of automated equipment are they mainly using? To do a pin or what? Or is it a special structure? Hold it, in there. What about the process? What we talked about. If it is the stability of a special structure, why don't we talk about it here? For example, a needle like mine. The design of my housing. It just happens to have such a structure. I'll add another lid later. Cover it in, right? Bury it like this. What about this structure? The implementation of a physical structure. Then the other structure is complete. We call this the interference structure. What about this interference structure? What did we say? In the process, it's damaging. It does hurt. What about this structure? We need to pay special attention. What about during the manufacturing process? It can't interfere too much. It can't be too small. How do you calculate this quantity? That must be practical with you. The data and interference of the generated force. Former positive proportional relationship. As for, this monistic relationship. Or is it binary? This, it needs to be verified through experimental data. What about this force? Yes, we must make sure. Otherwise, our condenser will fail a function. What about the insertion force? This is more complicated. Plug-in force. It is a fit structure. It's a combination of male and female. It involves the physical shape of the two terminals themselves. And your relative position and amount of interference. It has more actors, just like us. Single core connector. Single core connector with single hole. Its insertion force will be very small because it only has one hole, and its interference is either a circle or one dimension. When the second hole appears in my connector, except that my interference will increase by more than 1 yuan, there will be another dimension. It's in our male and female, the relative position of holes, and the relative position of the hole to the hole, one by one intervention. Of course, as you have more and more holes, the error of the relative position itself, and the accumulation of interference, that will cause your plug-in force, will become non-linear. Geometry is going up. For example, I have a terminal. I have a pair of terminals on one. In the case of one terminal, my insertion force is, say, half a newton. In the case of two terminals, it's definitely not 2 times 0.5. It should add a coefficient. That in the case of 3, it should be 3 times 0.5. Add at the same time. 3 coefficients. It goes exponentially up, not just a linear one. In this case, in our continuous manufacturing process, so everyone has to see it very clearly. In addition to the interference of my own monolithic, our relative position is very important. So where did this relative position come from? It's simple my accommodation, the hole on the structural part. The relative position of each hole. We call it the positive dimension. True position. Then this thing. Is it within our design scope? Or our accuracy is? Is the tolerance accuracy of the assembly good? This is very relevant. It's very relevant. And what about the process? When our products are applied? Our products are being applied. When? Normally. If it is in mutual cooperation or application. A certain degree of discomfort. Or if it doesn't fit. We need to go in this regard. Put some effort into it, especially for its own stability and consistency. A long-term stable monitoring is required.